Hi, welcome to a new edition of Building Site. I'm Malcolm Sparks. I've taken quite a long break over the summer to have a holiday and do various bits of business pieces, so I'm back now, hopefully doing a schedule about 3 times a week, and we'll see. We'll be doing it today, tomorrow and Wednesday, and right now I'm just going to introduce what I've been playing around with over the summer break, and mostly that's been GraphQL. But we'll check in with Alex and Joanna and the others to see what they've been doing, and Jeremy too, I'm sure. So for this episode, it was really just a warm-up, a test again, make sure that we can stream, and kind of introduce what I've been doing. So I've been working on a project which I think we've introduced before, called Grab. And Grab is a GraphQL implementation in Clojure. The difference with Grab is really that it can interpret the schema definition language, which is really a very important part of what we're going to do when we're building GraphQL on top of the site. So anyway, I'm just trying to get something working, which is this introspection query. So I won't really introduce very much more, just to show you kind of what I'm doing. I'll get a less classy keyboard to do this on. Okay, so here we are, and let's begin. So I'm going to start with an introspection query that comes out of GraphQL, and this is what we're going to try to parse, try to interpret. Right now, I'm getting a bug that I get this field error, non-null type returned nil value. Now I suspect that is because the schema says that it, oh well, in fact this, yeah, we have something, I've got to explain this. So the schema has to not be nil. Now I'm just going to pull up the relevant spec here, and we'll go down to the introspection part of it, and this will say that here we are, introspection. And this is saying essentially that there's a schema at the root query. In this case, my query here is going to be this introspection query, and it says that at the top of these root queries, you should have an underscore schema, and that's got to exist. And if it doesn't, it will be a schema, or it will be kind of some error. I've built most of the GraphQL implementation in Grab, so we're just kind of filling in the pieces now. This is quite fun, a fun stage. So let's. I suspect what's happening is that there's that we're just returning nil. So I just need to kind of find out why that's happening. But at the root of a GraphQL request in the implementation, you have something called a field resolver, and that is a function that's given some arguments and parameters, and its job is to come up with a value, and I suspect it's coming up with the value nil. Let's just see how field resolver works. Down here, resolve field value, which is actually referenced in the spec, section 6.4.2, if you want to see what resolve field value should do, but there's not very much really. 6.4.2 down here is just, let it be an internal function, and this is what we're going to call out to our implementation. So the field resolver is a function that I've given it, and it's here, this is the field resolver function. Okay, I will whack the font up a little bit. We're recording, should be recording in HD, but we'll see. Okay. Right, so the suspicion is that, well, how I've implemented it, said that there are some fields that are kind of implied. In particular, there's this underscore schema field, which always exists on the root. So what we do here is we call it with a delegate field resolver, and we say, hey, can you resolve anything for us? And this is where it will check query type kind. And now it's looking for the actual name of the object that is sort of in the context object. So if a context object is, for this example, this would be the very top of the tree. But it could be, if you're looking at, for example, a user and trying to get their details, then the object type would be user, and the name of that would be the string user. So I don't think that is correct, because here the name of the type is going to be whatever well, if we look at the schema, we'll look at the schema 3, the name of the type is going to be called root. Aha, but as part of the schema validation, I inject some special values. Let's just have a look at that. So when we compile the schema, there is a function here called Inject Introspection Fields, and this is cunning because this puts on the extra implicit or meta fields, they're called, and this is saying, right, you've got to be right, this is where it goes into the schema. Okay, it's all a bit tricky. As we go back down to the execution, I don't think that's right at all. I think that's why it doesn't work, because that would really that would really be, in this case, root, and there'd be a thing called root schema. And then we have to return something that will implement this schema. We'll just return the schema for now. Haha. But this will only work in grammars or schemas where the root query is called root. And it just so happens that it is there. So what we really want to say is, if what is the query root name? The query root name is, I'm going to show that here just by introspecting it. Okay, back here we'll have a little thing called schema, and there's a thing here called root operation names, and that tells us, if we can say get in schema root operation names. I've done this before, strong sense of deja vu here, and then we can say query and say, that's the root. So we can say root query name, and then here we can pop that to be root query name, and well, in fact that's Yeah. Okay. Okay. And this will be root query name, and we'll return schema. So let's see how far we get with that. Ah, that's it. Now gone a little bit further. It says now we can't, there's something that it wants the underscore type, but we don't know what the object is there. Okay. I wonder how far it's got. That's the crazy thing of starting with this really large introspection query. We might decide to break it up into lumps, but I suspect yeah. Field error. Let's have a look at where that is. Field error. It's down here. When the completed result is nil. Well, that doesn't tell us much. Let's find out. Yeah, that really isn't telling us very much. We don't really have much debugging information. It would help to have a path. The challenge with GraphQL is that you're implementing something that is essentially recursive tree walk. So the algorithm is itself recursive. It starts with this idea of selection sets, and then continues to resolve the fields on those selection sets, and some of the fields have their own selection sets, and all the way down. Right, I am going to pause. Okay, be back soon. Okay, we're back, and yeah, let's carry on. So, I'm thinking here that we need more debugging information, because this really isn't very helpful. It doesn't tell us where in the tree that we are. Now, we do have some tests that should still run, so I'm going to run those just if we are going to hack around. That may well be our, yeah, that's the problem that that's the test we're trying to fix. Now, I just do this, comment that piece out. Yeah, so we're still good there. So I'll just so we are trying to, we've got this as a schema. We're trying to run an introspection query, which is itself a piece of GraphQL, which looks like this. I grabbed this from the request that GraphQL was sending. Yeah. Is that right? Yeah, I think so. Okay, and what we have here is somewhere in the, down here, it's probably asking us for a type, trying to look up type. Don't know. Can't see it, it's all recursive. So let's just put another a thing called path there. This will be where we are in this big tree of recursion. And up here, let's put complete value there. We could do it this way, couldn't we? So whenever you're dealing with recursion, always useful to have path information. And as a general rule, when you're programming, it's always better to throw as much information as you can, collect it all, and then let the debugger or your future self have as much clues, many hints about what's going on, as much data as you can collect, so that somebody can fix your problem. Okay. And it's really difficult coding like this. I've forgotten how hard it is, but I think it can be healthy as well, because it forces me to explain to people watching this, try to understand it myself and to try to explain it, and that's really hard. Sometimes I found over the summer, if you do get into a frame of mind where you can just program and especially tricky stuff, where you get into a kind of flow, you get into the zone, and you manage to get progress. Well, this is a different style. We'll soldier on here. Okay, and all right, let's go to run this. Are we going to get an arity error if we? No, we're not, because this is just going to be nil. So when we say complete value, and oh, this is a recursive thing. Okay. So every time we do complete value, we will. This was the. Let's do this. Every time we call complete value, we've got to add a path. Now, what's that going to be? And this is an inner type ref. So this is more like your inner type of list. What's this? Execute field. Okay, this will have to have path in it. Oh. Okay, execute field. Another thing that we can do is blow up if we don't get given path. That's going to help. Okay. So blow up if you don't get path. So we don't get it here, which means that we can kind of go down our stack and say, okay, it was nil here. So we could put a little assert path here. Now I've decided here, for various reasons, to make all of these a map, an argument a map, rather than just having positional arguments. That might not have been a great idea, but there we go. So here we have, just playing around here, there's a missing path here, hence the error path. Now what's the path here? We're navigating down a field. This is a thing called execute selection set, for which we have a field name. Okay, let's chuck that field name in. Path field name. Great. And we'll assert path. What's it? Path will have to come in here as well. Let's go back to run it. Okay, there we are. there's a missing path. Pop it in there. Now this is just executing the query, it's not doing any recursion or anything. So, but there's a good chance, this is a good chance to initialize the path to the empty vector. Okay, good. Bang, assert for, there's no path there. What's this? Execute selection set. Normally, we've got to put it there. Now this would be object interface or union, so we would need to put in the well, I think we can say object type. It doesn't matter because it's all debug information. We can have it. Here we are. So the path is we're putting the whole so we are executing, and so essentially we're here. The root query name is root. The name of the object type. See, we're getting object type here. The name of this is the object type, and the name is schema. So what we're missing is schema. I don't think it's very useful to have the object type there. So I'm going to back up, and where do we put that path? Down there, where would you put the object type? Here it is. We'll just put the name of the object, which is blimey. It's the name of the field type, I think. Name of this field type, I think. Yeah, that's kind of more sensible. So we look at our query, and it's saying, okay, we've gone down to schema here. We're here. Then we go to the not null type, because the schema says, or rather, yeah, we kind of injected it in to say it had to be null. I'll show you that bit. That's some trickery we do when we inject. Here we say, oh, we'll get rid of that. We go, this is the type, __ schema is a not null type of this. This is like a type, we call it a type reference. And in this case, it's a field definition which has a not null wrapper over a so this is what's happening here. We're here because we're recursing through or calling through the non-null type, getting to schema, and then we're saying, hey, what's query type now? It must so happen that in our meta schema, this meta schema, by the way, comes from where does it come from? Here, schema introspection. It's all copied from here, even the comments. That's where it comes from. So what's happening is that there's a thing called query type. Right, so schemas have to have all of these things defined on them. Yeah, they have to have types. Okay, and types is a list of types. So, okay, when we execute, we have this chance where we introspect. I'll take this one out now. And here's where I suppose we could call it an interceptor. We intercept the call and we just say, aha, are you looking for these special meta fields? So we can resolve those fields for you because we know the schema and we know the document. If it's anything else, we'll have to ask the user. So we can resolve these internally in the library. And okay, so in this case, we are here, schema. I put this conp thing. If you don't know what conp, don't worry, but it's essentially making a case statement that's easier to read. So here we're saying looking for query type, so object type and field name. And here we've got to return a list of types. Now, I have to show you what a schema looks like when we've created one. Let me show you what a schema looks like when we've compiled. So I have a thing here called provided types, which is all of the types in our system. So let's have a play around with that. If we looked for provided types and said, oh, just give me the keys, you'll see all these types. I'll sort them, that'll be fun. Okay, all built-in ones, some that we've brought in from the schema, our own schema, and some of these meta fields. So those have all made it into our schema. So what we're doing is giving if you look at the values of these things, all these things, this is the list of types. Good. Might sort them. Okay, but we can do that here, and we'll do sort by, and we'll return it. Oh, so easy. So it's kind of GraphQL eating itself, because even though we're sort of using the, it doesn't matter. We're trying to get the GraphQL. Let me try to explain it. We've got a GraphQL schema here, and we're trying to write a GraphQL query on the schema, not on a kind of piece of user data, but on the schema itself, because schema is just data. So GraphQL, that's kind of model of GraphQL, treating schemas just as data, very much aligns with our philosophy in JUXT that what we call form, that is the same thing as schema really, is something that should be encoded as a data structure and not encoded in code. And therefore should be datafied, not codified. So the downside of that approach is that it does lead to some very abstract code. But, you know, code is powerful. It's something, you know, we say a lot is that you should only use code when you need to. The things that are code is a very, very powerful tool. So you should only use it in extreme situations, and mostly you should use it to write compilers or interpreters, i.e. things, as we are doing here. We are writing, in this case, an interpreter that is interpreting a document with respect to another input, which is a schema, and it can be, and another input, which is a function. So it's an interpreter. Execute request. So because it's an interpreter, we're allowed to code it. Right, okay. Query type. Oh, is that no? Well, because did we actually code query type? No. Yeah, we did. Did we reevaluate that? Maybe we didn't. Okay. Now we've hit another error. Oh, I love this. I love it when you get to a point where you can just be lazy. And just get the computer to tell you what to do. Alright, next one, schema types. So we go back to our, and we say there should be a thing called types here. And we may have to go back to the, find out what do we meant? No, that's the type. Let's just write to-dos here. We're going to have one query type, which is going to be start with the schema. We do a sum here. Then get the map of provided types. There's another way of doing it. You can start with the root query type, query name, and then you can apply the provided types, and that will get us back our type. Hooray! That will be query type. And then for the others, I'm going to say, right, mutation type, probably don't need, I don't know, we'll just throw an exception. Unimplemented. Are there going to be more? Subscription type. And directives. Well, for now I won't need to support those. Don't know, but we'll just say they're empty for now. Now those things that we're returning become, that thing here becomes the object value for the next layer of recursion. Okay, so that's what object value means. You start off with no object value, and then the first thing that you select in the tree, and as you recurse down, that thing becomes the object value, and then it's kind of, that's the node in the graph, and then you kind of find some other node and you hold on to that. So the object value, the object is always the thing, the sort of context object. So let's see where we are now. unimplemented. Right, which one? This one, mutation type. Why? Because the introspection query, which is here, probably at some point wants to know the name of the mutation type. Why don't we then return, we could return an empty map, that would be better than nil. Well, it does say, actually, here, it does say that we're allowed to return nil because it's not a non-nil. That's what the bang means. It means you have to return something that is not nil. So we will return here, let's just return nil, both of those. Well, that worked. I wasn't expecting that to work, and it did. I don't think GraphQL is going to like me. But, wasn't really expecting that. But that's okay. I suspect this looks okay. Well, let's dive in to find out why the type. So the first thing this query does, once it finds the types, it will then wants this thing called the full type. And it may be that we haven't implemented fragments, because we would expect something like a full type. Okay. So I think that's okay. It's just this thing called a fragment spread operator is saying bring in kind name description. So what I might do just here, well, I'm going to do something really ugly and just have a version that I can play with, and I'll just say name and kind there, just to see what happens when we do that. So I'll slurp in a modified query, and then we are getting some type information which would lead me to suspect that the fragment spread operator is not working. So let's have a look at selection set evaluation. I mean, I'm pretty confident we could get this done because GraphQL does tell you how to do it. So there's a thing called, I guess it's called field collection, which, yeah, it's this collect fields, and I bet you is because I just have been lazy and I haven't implemented everything. So let's have a look at this collect fields function. Fragment spread, definitely something going on there. I'm not sure I like this to do there. So something's going on, isn't it? So this is section 3D. Let's see how much we have done. I mean, what's going through? I mean, this is a big test. There is no question that this is a big test. Let me just get rid of my changes there. And the granularity of the test is too big, too coarse. We could create some little tests. However, while little tests would help us figure out the problem, it might not help the production support person who has to still figure out what's going on without the support, without the ability to run small fine-grained unit tests. And therefore I still feel that we should try to debug this as if we were debugging something in the real world. Because if we need to put in extra hints and extra guideposts along the way, then we should do it now. And that might come across as a contentious position. There's a lot of people who advocate writing small, fine-grained unit tests. And I do too in certain circumstances, especially when you're in discovery mode and you're trying to you're trying to build up an API that you don't know what the API is going to look like. In this case, we don't really have any questions about what the domain is going to look like. It's been defined for us. And I'm really more concerned with doing some nice error handling and sort of writing serviceable code. So I'm putting myself as a programmer into the position of the person being, doing the debugging, trying to get my head into that situation and to make it easier to debug. So, let's, in this case then, put this throw back in the game. It was there for a reason, I bet. And let's see, we are expecting it to blow up. No, it doesn't blow up. Oh, we did re-eval, probably. No, it still doesn't blow up. Let's blow up. Let's blow up here. Let's blow up. Good. So satisfied that. Now you may ask, why don't I use a debugger? Why am I sort of putting these breakpoints in, which are just exceptions? And I guess the reason for that is the debugging experience is quite taxing. You have to set a breakpoint, and then when you're at the breakpoint, you've got to make sure you just collect all the data around you, and then if you forget to, and then you have to sort of step through your code and try and reason about it. In, I guess, functional languages, is it true? Well, we can almost automate that debugger by just coding it, and coding the things that we want to do. Anything that we want to evaluate, we can evaluate here, and then just chuck it out as a breakpoint. And it is a kind of breakpoint. Anyway, a breakpoint that it's not handled. Right, and let's, well, we don't need that, I guess. No, we don't need that. We just need the fragment here. And we're expecting to see this fragment nil. Oh, well, that's possibly the problem. There is no fragments by name because we haven't created one. There's nothing in the document. So let's have a look at what our document looks like. And again, the document is actually this introspection query. So we're going to expect that there's going to be some fragments here, and these fragments are going to be in the document. There's no errors, so we can say that is quite, so what we're seeing here, I think we've got four things in the document, and that is this thing here, which is the query, and 3 following fragments. There we go, there's the third one. And what other things? We have fragments there. We have operations by name, but we don't have fragments by name. How do we get it? Well, operations grouped by, okay. And that is because we have elected to build up the document and validate it all in the same pass. There's a reason why you sometimes need to compile and validate at the same time. You might think you can only, you should validate before you compile because that makes the compiler easier to write. But sometimes the validation needs some interim values in order to validate the interim values, and interim values can only be created by compilation. So it's a bit of a chicken and egg, which is why you tend to find when you need to do complex validation, you're also building, doing the job all at once. So here's the validation part, which I didn't get very, well, I got quite far. Let's look at the validation source code. What was it? I think I just did it here. So compiling document will do all of these steps, and if we look at the tests, I think I ran out of steam about example 114. If we go down to 114, yeah, we were down here 5.3, which is 5.3, which is to do with fields, and fragments is 5.5. So we validated 5.1, 5.2, and most of 5.3. Still got to do 5.4. Yeah, we're not even halfway through. So I think I'll wrap up today. I think next time we'll just slowly keep going through these tests and trying to validate the document. And what we will need to build up is that fragments by name. So if we look at 5.5, and this is quite a lot going on here, but we will validate the fragments and then we'll create that fragment index. Okay, so I think that's enough for today, kind of getting back into the spirit of it, getting back into the flow. And how long have we done? 51 minutes, so we've done quite a big episode today. I'll upload it to YouTube. Thanks for watching. I think it might take another 4 or 5 sessions. We might focus on GraphQL before we go back to card and our ambitious, well, you know, partly the reason we're doing this GraphQL is to serve the card application and other similar applications built on XT and site. So there we are. All right, well, thank you very much for watching and see you next time.